Welcome to our discussion of chemical reactions and equations. In this lesson, we will learn how to read chemical equations, determine what information chemical equations tell us, and identify the main types of chemical reactions. So what are chemical equations? Well, essentially, chemical equations are just a way to easily represent chemical reactions. So if we look at this particular chemical equation as an example, we would read this as hydrogen gas combines with oxygen gas in a reversible reaction to form liquid water. From this one chemical equation and others like it, we can identify the products and the reactants. We can tell the direction that the reaction is proceeding, whether it's reversible or irreversible, what states our reactants and products are in, whether they're solid, liquid, gas, or aqueous, as well as the ratio of the amounts of reactants required and products formed, along with several other things such as energy or heat or light or any catalysts that are needed within this particular or for this particular chemical reaction. There are many different types of reactions that exist, but we're going to focus on 5 of the most common. The first type of reaction we're going to look at is a synthesis or a combination reaction. That's where we have 2 or more reactants combining to form a single product. So for example, the first reaction we looked at already, hydrogen gas plus oxygen gas gives us liquid water, is a perfect example of a synthesis reaction. Another type of reaction is a decomposition reaction, which could be thought of as the opposite of a synthesis reaction. This is where we have one reactant decomposing or breaking down to form multiple products. An example of this is the decomposition of iron 3 oxide into iron and oxygen gas. Our next type of reaction is a combustion reaction. This is when we have a substance, usually one containing carbon or hydrogen. It can sometimes even be a metal if we're talking about oxidation or rusting, combining with oxygen gas to produce carbon dioxide and water. So for example, we have C10H2 combining with oxygen to produce CO2 and water. And with combustion, one of our reactants is always going to be oxygen, and our products are always going to be carbon dioxide and water. In a single replacement reaction, we have a lone metal in our reactants swapping places with the other metal in the compound reactant, or we have the single non-metal reactant swapping places with the non-metal portion of the compound reactant. An analogy for this, or a way to remember how single replacement reactions work, is think about a prom date. We have a single girl going to prom and a couple. After prom, that single girl has stolen the other girl's date and they've left together, and the girl that came with her date is now left alone. So there was a swapping. Our 2 girls swapped, and one started out single and ended up with the date, and the other one started with the date but ended up single. So a real life example of this would be when we have potassium chloride and sodium as our reactants, and our potassium and our sodium, both as our positive metal cations, swap places to produce sodium chloride and potassium. Finally, we have our double replacement reactions. In these types of reactions, our reactants are going to completely break apart, and our metals and nonmetals are going to recombine to form brand new substances. An easy way to remember how this new combination is going to happen is outsides and insides. Our outside elements are going to combine and come together, and our inside elements are going to combine and come together. Just remember, when you're rewriting your new compounds in the products, that your positive cations or your metals always come first within a compound. If we were to revisit our prom example with a double replacement reaction, it would be like 2 couples going to the prom and leaving with each other's dates by the end of the prom. A real-life example of this would be sodium chloride reacting with potassium bromide to produce sodium bromide and potassium chloride. And that concludes our discussion of chemical reactions and equations. Bring any questions you have with you to class.